Okay, for 7.5, we're looking at volume and surface area. So lots of definitions for us to make sure we understand. So geometric solid is a three-dimensional shape bounded by surfaces. Common solids include rectangular solids, also called prisms, spheres, cylinders, cones, and pyramids. Definition of volume is a measure in cubic units of the amount of space occupied by a geometric solid. So essentially you're filling the space inside. You're filling that up. A rectangular solid or a prism is a solid in which all sides or faces are rectangles. Now, most common prism is going to be a rectangular prism. Looks kind of like this. And then if you want to do like your dashed unseen lines. Okay. However, there are other prisms. Prisms are named by the bases. So a prism has two bases that are parallel, and then all the other sides are rectangles. So it's named by the bases. So if the bases are squares, we would call it a square prism, except we end up then getting into like cubes and all of that if they're not rectangles, but instead squares. We have rectangular prisms, and the most common would be the right rectangular prism. But we can also have pentagonal prisms, hexagonal prisms, any of them really, decagonal prisms. It just depends on the base. Definition of a cube: it's a type of rectangular solid or a type of prism in which each side or face is a square. Definition of a sphere: a solid in which all points are the same distance from the center. This is your typical ball, basketball, baseball, tennis ball, soccer ball. Any of them would be examples of a sphere. A right circular cylinder: a solid in which the bases are circles and are perpendicular to the height. This is like your typical pop can, paper towel roll, anything like that. A right circular cone: a solid with one circular base and sides that come to a point called the vertex. So this would be like your ice cream cone turned upside down. And then definition of volume. Didn't I already do that one? Sure did. Yep. Finding all sorts of mistakes tonight. Definition of volume: a measure of the amount of space. Well, I don't even have it right on here. Okay, that's wrong. Just cross it out. It's already here. Okay. Definition of regular pyramid: a solid in which the base is a regular polygon and the sides are isosceles triangles. Okay, so for our pyramid, hold on, I have to remember how I usually draw this. We have the base has to be one of our polygons. So square, rectangle, pentagon, heptagon, decagon, octagon, whatever. Then the sides are all triangles. It's named again by the base, so it would be like a square pyramid, a rectangular pyramid, an octagonal pyramid. And then slant height is going to be important. Slant height is a height that doesn't come down at a right angle and instead goes up the side. It's actually the height of one of the faces. So if we took like the face, the side triangle off the pyramid, and we found the height of that coming down to a right angle, that would be called the slant height. And we're going to need that for some surface area formulas. So these are our volume formulas. We have for a prism, length times width times height. for a pyramid, 1/3 the length, the width, and the height. So notice the difference here, this and this. The right angle down the center of the pyramid, that's the height of the pyramid. The distance down the side of the face, that's the slant height. A cylinder would be pi r squared h, so basically the area of the base times the height. Cone would be 1/3 pi r squared h, and then sphere is 4/3 pi r cubed. I recommend you write these formulas on your note card. All right, so here we go. Find the volume of a cube that measures 1.5 meters on a side. So a cube is a type of prism, so we're going off of our volume equals length times width times height formula. Because we know all three of those things will be 1.5, we're doing 1.5 times 1.5 times 1.5. This would be 3.375 meters cubed. Volume, remember, is always cubed units. And you could round that off if you wanted to. Bless you. Okay, example 2. The radius of the base of a cone is 8 centimeters. The height of the cone is 12 centimeters. Find the volume of the cone round to the nearest hundredth. So volume of a cone, 1/3 pi r squared h. So we're going to plug in what we have. 1/3 pi 8 squared times 12. Okay, when we are calculating this, we are going to do 8 times 8 first and get 64. Then we're going to multiply by 12 and get something. 768. Now, when we're multiplying by 1/3, what that means is we're dividing by 3. So then we're going to take that 768 and we're going to divide by 3. That's going to give us 256. So if you are asked to give an answer in terms of pi, you would do 256 pi centimeters cubed. If, however, you're asked to round it off, then you're going to multiply by that pi button, and you'll get 804.25 centimeters cubed. Questions? All right, next example. An oil storage tank in the shape of a cylinder is 4 meters high, has a diameter of 6 meters. The oil tank is 2/3 full. Find the number of cubic meters of oil in the tank. Round to the nearest hundredth. Okay, our formula for volume of a cylinder is volume equals pi r squared h. How do you think this formula has to change for this problem? It's 2/3 full. So we are now going to be calculating 2/3 pi r squared h. Okay, so am I just going to plug in 6 and 4? Why not? The diameter is 6, so the radius is what? 3. All right, so we're going to do 2/3 pi 3 squared times 4. And I want to walk through how we're going to calculate this step by step. So we're going to do 3 squared first, and that's 9. Then we're going to multiply by 4. That's 36. Then we're going to multiply by the 2 from 2/3 because that's on the top. That's 72. And we're going to divide by 3. Are you tracking with me how we're multiplying these? So all numbers across the top, then we divide by the bottom. Okay, so we would end up in terms of pi with 24 pi meters cubed. However, if we are asked to round our answer, that would be 75.4 meters cubed. Questions? All right, let's look at just 3. That's nice. Okay, surface area. So definition of surface area, you take the area of all sides of a solid and add them up. So our units for surface area are going to be square units, not cubed units like volume. All right, so our formulas. For the sake of these formulas, I used a capital L for length and a lowercase l for slant height to try to give some clarity. So like this, these two are length. This one is slant height. And this one is length. And by length, I mean length of the base. This one is slant height. That should be all of them. Okay. Again, I recommend you put formulas on your note card. All right, last 3 examples. So, diameter of the base of the cone is 5 meters. Slant height is 4 meters. Find the surface area of the cone, round to the nearest 100th of a square meter. So, surface area of a cone, pi r squared plus pi r L, slant height L. Five and 4? Why not, Annika? Good. So R is going to be 2.5. So pi times 2.5 squared plus pi times 2.5 times 4. Okay, so first thing we're going to do is deal with our numbers individually. So we're going to do 2.5 squared and get 6.25 pi. Plus, and we're going to do 2.5 times 4 and get 10 pi. Now, pi kind of functions like a variable in terms of like terms. If 2 numbers have a pi, we can add the 2 coefficients together. So this is the same thing as 16.25 pi, because I can take my 10 and add it to my 6.25. If I wanted an answer in terms of pi, I would leave it like this and just add meters squared. However, if I'm multiplying this out, I'm getting 51.05 meters squared. Questions? All right, example 2. The width of a rectangular solid is 32 centimeters. The length is 60 centimeters. The height is 14 centimeters. That looks like a W. What is the surface area of the solid? All right, so rectangular solid, also called prism. Our surface area, we are finding, did I write surface area on all these? Okay, good. Surface area is equal to, okay, if you look at your formula here, essentially what you're doing is you're finding the area of one side, so like a length times width, and multiplying it by 2. And then you're finding the area of another side and multiplying it by 2. And then you're finding the area of the other side and multiplying it by 2, because you should have 3 pairs of sides that match. Because of that, I've kind of broken it down this way, like 2 times length and width, 2 times length and height, 2 times width and height, add them all up. So we're going to go ahead and do that. We have 2 times 60 times 32 plus 2 times 60 times 14 plus 2 times 32 times 14. And really the order doesn't matter as long as you've done all pairs of those numbers. So this would be 3,840 plus 1,680 plus 896. And all of that added up would be 6,416 centimeters squared. Any questions? All right, last example. Find the surface area of a sphere with diameter of 15. Write your answer in terms of pi. So diameter of 15 means a radius of 7.5. Surface area of a sphere is 4 pi r squared. So this is going to be 4 times pi times 7.5 squared. So what we're going to do is we're going to do the 7.5 squared and multiply by 4. That would be 2.25, 220, I said that wrong, 225 pi centimeters squared. And that would be your final answer if you're asked to leave it in terms of pi. Any questions on 7.5?